Okay, excuse me. So here we go. Our next example. In this case, I have a box that's 1.5 kilograms. It's being pushed with an initial velocity of this, and it's allowed to slide to a stop. Now, I automatically know this is an unbalanced situation because it is sliding to a stop. It will have a change in speed. It will accelerate. It'll be a negative acceleration because it's slowing down, but it'll accelerate. So when I go to draw my free body diagram, I'm still on a flat surface. So I have my normal force, and I'm still dealing with gravity on Earth because it still exists. We're still on Earth. But in this case, I only have a friction force. I have no applied force because I'm not touching it anymore. When I let a box slide to a stop, I had to push it and let go. I'm not applying a force. There is no applied force. Why did it keep going for a little bit? Well, it took some while for friction to remove all of that inertia. It still had inertia, not a force, but a property of matter. These relationship is important because what it does is it sets up my understanding that the net force is going to be whatever moves it forward, no force, just the inertia, minus the force that's slowing it down. Once I know the friction force, I automatically know the net force. And what will the net force get me to? Well, using Newton's second law, acceleration. But let's start at the beginning. Let's start by finding our friction force. And to find our friction force, we're going to do the first mathematical step we will always do with every friction equation that we have done and that you will do in grade 11. And that is find our normal force, which is equal to our gravity force. And that's because we're dealing with flat surfaces. Flat surfaces, they are equal to each other. So we can just find it. So 1.5 times 9.8 will give me my number of 14.7. So this is my, and I'm not going to round it because I'm not done yet. So that is my normal force. Why is it important? Well, because we can remember the friction equation. The friction equation will give me my numerical value for my amount of friction. And I have everything I need to solve for friction right now, right? I know my coefficient, that's in the question, right? 0.26. And I know my normal force. So I'm going to multiply and find my value. And I find my friction force is going to be 3.822. I'm going to keep those digits because I'm not done yet. This is not my final answer. I like to keep my accuracy and do my rounding with sig figs at the end. Now I know this number because of this relationship that the net force is equal to the negative friction force. That means the net force is also going to be negative 3.822 newtons. Now we're going to stop there just for the moment because I don't want to run out of time, and you can watch the second video to continue this problem.